Okay, can you guys hear me okay? Yeah. All right, great, thanks. So this talk is also meant to be, if you want, interactive. So if you have a question, I'm happy to stop. It's definitely an introductory talk, so if something's confusing, put your hands up, and if I feel like I can't answer it now, I'll be like, let's answer it later. So welcome to the talk on learning Nix the fun way. First off, this talk can be found online. There's the URI. And this is a reprieve of a talk I gave at Planet Nix. So if you heard that talk, nothing's really changed. You know, my goal is to just spread Nix and some of the fun parts of it. A lot of it can feel overwhelming and academic. I welcome improvements, edits, and corrections. And yeah. Okay, so just really quick, let me introduce myself. I'm Farid. I currently work at Confluent. They're like known for Apache Kafka. That's some software project. I don't work on that. I work on build systems and automation and developer productivity. I've been using Nix in a variety of capacities for a while now. I've presented at a bunch of NixCons, North America and Europe, and I had the pleasure of bringing Nix into Google through an acquisition at Looker. I'm very bullish on Nix. It's been a source of mostly joy. And I had the fortunate experience of leveraging it to complete a PhD. So this thing says nearly complete. I completed my PhD as of June. So yeah, I'm very happy about that. Okay, so that was like the alternate working title for this talk. And I want to share effectively why I love Nix. Love is a strong word. But Nix has brought me a lot of joy, simplification of my software life, and ultimately love. You know, sometimes though it's felt like learning it can be challenging, and I find it's really important to find like the purpose of what I'm learning and why. So ultimately, like why I love Nix, and you should too. I've given a lot of talks about Nix. I've given talks to meetup groups, friends, plenty internally at the companies I've been a part of. And this is kind of a photo of, in my mind, when I'm thinking about wanting to talk about Nix, talking to others. It's like a noble pursuit where I'm imparting knowledge to my apostles about like what they're missing out on, and they're gaining some infinite wisdom, and it's somewhat academic, the whole thing. I tend to always begin these talks covering the like Nix as an idea started from a PhD thesis, and for some reason I can't not mention the PhD thesis. I think it's like a law when you do a NixCon talk, or a Nix talk, sorry rather. And the PhD was the purely functional software deployment model, and it was in 2006. In retrospect, when you start off with a thesis for a talk, this slide better depicts how the talks have gone. People in attendance are totally bored by the nuance and complexity of what I'm talking about. At worst, I've immediately turned off potential new Nix enthusiasts by immediately jumping in to like an academic and incredibly verbose vocabulary about the ideas and technologies about Nix. And I've just lost a willing convert. Okay, so the motivation of this talk is like, I want to do it different. Let's learn Nix the fun way. You should be sold why Nix, what's fun about it, why do you want to use it. You know, it's going to be a little bit of a crash course, but you should come away with like, wow, there's some benefits here and it's fun to use. I want to impart the benefits of using Nix by what I believe to be learning Nix the fun way. Okay, let's begin. So there's going to be some code samples. I apologize, can't get around it. It's a code thing. Let's begin with something seemingly innocuous. This is a script to determine the IP of my current machine. Looks pretty standard. I'm hoping most of the people here are probably reminiscent of a lot of scripts that might have looked like this or written themselves. And it stitches a few programs together. So we have bash, curl. JQ is this tool, if you're not familiar with it. It processes JSON and you can pull things out of it. So I run it, and I get the IP of my machine that I'm running from, or the gateway, or whatever. Here's what rewriting that same script in the most raw form of Nix would look like. Oh God, you're scared, right? Like, you wouldn't write this. I know I just showed you a new language, but just ignore that for a second. The only takeaway is it looks like, okay, if you squint, it's new, it's scary, but if you're programming, it should look like JSON. It looks like other languages on the face of it. So it's not like totally out there. That's the important part of this recipe. Okay, it looks to like the script we wrote before. Okay, so there's like a direct mapping. I'm pretty happy here. But of course, that's not what you'd actually write in Nix. The following is a little bit more idiomatic and a lot more terse. And right now we're getting a lot closer to the original script we'd written. So this is how you'd write that first script in Nix, and I'll show you like why you would want to do that anyways. So for those that might want to follow along now or later, it's important to keep note of this commit value and that I'm building this on an AMD 64 Linux machine. Okay, so Nix, I wrote this like thing that I'm telling you should do for this script. Why? Well, let's see, let's build it. Okay, you get some output. It has the name, what is my IP? Okay, that's cool. Inside of this path is a script, and it's that script we ended up creating. We can execute that script, and it works as we expect. That's the original IP. So we're functionally identical so far. So far, so good. I didn't lose functionality. This is great. Okay, but why did we go through this whole thing? Why did I, make you learn a superset of JSON, basically? Why do we even need Nix? Like, what's this file? What does it look like? Okay, so the output of the script actually looks really similar to what we might have written offhand at first, except everything seems to be prefixed with this really long string. So you can see that everything has a Nix store, something in front of it, but for the most part, everything's identical. Okay, although I promise not to get too academic into Nix, this part is important. What is that garbled string at the front? Ahead of our build script? And similarly found within the script before each of the tools. Well, Nix has a handy command, and it could show us what is that script, what does that prefix mean? So you could write Nix derivation show and give it the path. Okay, so the whole purpose of Nix is to kind of build this file. Why did we go through all that setup of writing that recipe? Is ultimately to produce this, and it's the recipe of what it takes to build our IP script. It has the build command. It has the text of the script, which may be also the source code. It has the input tools we needed, so our script needed bash, JQ, curl, for some reason this thing called standard env. It also has the system we're running on, and as well as the architecture and operating system. So all of this is hashed together to give you that garbled string at the absolute top. So that's actually a really mind-bending property. Because when you see that garbled string, that means we actually have incredibly strong guarantees about our build recipe, because the build recipe includes other garbled strings that represent other garbled strings that represent other garbled strings, and so forth, down to the source code. There's a level of recursion here that means repeatedly seeing this hash is an incredibly strong property of reproducibility. You can train your eye. If I see the same string, I have this incredibly strong property about the whole tree of software, whatever the root of what you're building is identical down to the architecture, source code, tools, and then recursively at each of those levels. In Nix, you spend a lot of time wiring things up to basically model things as a graph. Turns out, once you have a graph, everything you might want to do in software is a permutation or transformation of graphs. That's all we're doing. So I built the thing in Nix. I can now have it visualized as this graph, and Nix gives me a handy command to do so. And here is that graph. This is the full dependency graph of that seemingly innocuous script. So in software today, like, we are taking on so much implicit dependencies we don't know about, and Nix like makes those extremely evident and explicit. So I don't know, we see JQ, and for some reason there's KRB5. I think that's Kerberos. I don't know why. To build libcurl, I'm sure, because it has a bunch of dependencies and on and on. Okay, so here's another Nix snippet. Again, ignore the actual syntax, but know that we're defining here a shell environment. So you're working on a project, and you want to define a set of tools to build your project file, to build your project. And remember that garbled string at the bottom. We import our same script as I did before, and we add it into our shell. So I'm saying I have a shell, and I want to use this tool. Then you can enter the shell. Where did I? Okay, so you can Nix shell and you enter the shell. I see the little shell hook I did just to show you we're entering a shell. I can say my path now contains what is my IP, so I can say which on it, and it'll find the same path of the binary, and more importantly, it finds it at the exact same prefix that I had built earlier. So now I'm taking that exact same binary and moving it into an environment for a developer, and I know that that developer has the exact same binary and all its dependencies with an extremely strong invariant. And it's also good, it runs and works as we expect, because if it didn't, that would be a big waste of time. Boom. To me, this was huge. Did we realize what we just did? We just created a simple way to bring reproducible developer environments for projects. You don't need to give a Docker file, have people enter namespaces, network namespaces, volume mounts, doing non-reproducible steps. This is a way to be natively giving reproducible packages across individual developer projects. And you can easily validate it thanks to that prefix hash. But this goes even further. We actually know everything about our code now. We can do binary or source deployments. Like, again, when we have that graph, we can take that graph and move all the pieces of that graph, which represent files on your machine, onto another machine. And we like to colloquially call that a deployment. So Nix makes this really simple. We simply copy those paths from one machine to another. And they don't even need Nix installed, because you're just moving it from a folder to a folder. Boom, deployments. I don't need some crazy fancy machinery or whatever to get perfect reproductive deployments. Yeah, question? Yeah, the question was, will this only work if you're on the same architecture and operating system? That is correct, unless you have bin format and you're doing emulation. But you can build on one machine for the target host, because you can cross-compile relatively easily in Nix. So the idea, though, ultimately I want to get across is, like, when you have a graph of things, you just move the graph of things to the machine and you know it's perfectly going to work. I don't know how many of us have ever been like, I built something here locally and I installed it there. Oh wait, it doesn't have libSSL, or it has libSSL at 1.0 and not 1.1. You've captured everything down to libc, like the fundamental library in Linux, and you move that over, and you know everything's going to work perfectly. So here's one such command. There's a couple ways to do it in Nix to copy the graph we saw earlier to another machine. In this example, we're leveraging Nix copy, but you could do something as dumb as SCP or rsync. I didn't mean to call you dumb if that's what you use. I just meant simpler. So the items are copied over, and let's log into this machine. And I ran the path, and notice it's the exact same path that is present there, and I run it. So it's that same prefix string. So that means for it to have run, because it points to other very specific paths, all those paths were there on that other machine, and it all works and wires and runs. So I moved that whole graph over. Wow, we just did a deployment of not only our code, which was the script, but all of its necessary dependencies, such as curl, JQ, and bash. This blows my mind. Like I said, I can't tell you the number of times in practice I had to coordinate the runtime needed on the host for some base library not being present or whatever. Simplifies it a lot. Okay, well maybe that's a bit aggressive for deployments, and you've already drank the Kool-Aid of Kubernetes. No problem. Since we know the graph, and again, everything is merely a transformation of a graph, we can turn that into an image. So here's another snippet, and again, ignore the syntax, but know this is creating an OCI compliant image. We set the commands of our image to be our what is my IP package. And just like that, next slide. So let's go build that image. So the output of it is a tarball, because an OCI image is a tarball. We can load that tarball into a Docker daemon as normal, or you could do this through whatever, a registry or whatnot. Okay, I could run the tarball, or run the image effectively, and it works as we'd expect. I get the IP because the command was the IP. I can inspect the image, and we yet again see that the same prefix hash on our package for the command to execute is there. Again, this continues to give me those warm, fuzzy feelings in the inside that I've now produced an image that I'm deploying, and it has the same prefix hash. Cool. So we have Nix and Docker integration perfectly. The image produced only has the files exactly necessary to run the tool. So I've also done effectively distroless, which is all the rage right now. So you don't have any other base libraries running around. You've built an image and a file system exactly with what's needed to run the command or the application therein. And honestly, you could do the same. There's plenty of other slides here. I'm not going to show you every variant, but everything's just a permutation. We did OCI images. You could do a random assembly tarball. You could do a self-extracting zip. You could do RPM. You could do a Debian. You could do a Flatpak. You could do an app image. Because you've spent all the time setting up your graph. Well, a Linux distribution itself is actually just a collection of packages. It's a permutation and a collection of software files. Turns out you could also build an OS out of Nix itself, and that's what NixOS is. So again, ignore this is like a very basic config setup for a NixOS image. You don't have to care about the syntax, but what's important was we're setting one up, and I'm importing that same package, and I'm telling the OS image, include this as a default package within the image. And I'm starting it as a VM, just so I could demo it. But you can build an ISO or whatever and then boot into it. Okay, so like everything else, we build it. So I'm building my VM. Again, keeping in mind we want to look for this prefix hash. We get an output directory. Okay, and within that output directory is a run script to run KMU. I'm going to run my OS with some fun command parameters just so I can see stuff in the TTY. It starts to log into NixOS. I log in. And again, I execute what is my IP. Looks like I found it. It's on some other symlinked path, but then I say real path. I get to the underlying symlink, and I see that warm, fuzzy feeling again. I see that same prefix hash. So now I've built an OS distribution that has my software package perfectly reproducible with all its dependencies in that same OS. I feel happy inside. I feel joy, and yeah. And it works because we ran it. Oh, that was it. Yeah, thank you. Questions, yeah. And I'll try to repeat them. A Nix, I think the question was, can you do a NixOS module?
Yeah, like the configuration around a binary.
Yeah, I mean, the question is, can you do a NixOS module to configure a Docker image? Sure, I think you could. A module is just another level of abstraction to set up code, and I could see if you have a very consistent pattern for building your OCI images, you might not want them to have to write something closer to a Docker file and write some other higher level thing that you end up emitting the OCI tarball for. So totally. Okay, the question is, where is JQ and curl coming from? That's a good question. So it would be incredibly tedious to have to rewrite the world yourself. Thankfully, there's a large community that has already done that for you, and that is called Nix packages. So there is already a huge package set where authors have already taken the painstaking time to do all those dependency edges. So you don't have to always start from scratch. And it's also the world's largest package set by at least one order of magnitude, I think. Yeah, the question is, there's Nix Package Manager and NixOS. Yeah, naming in Nix is hard. They don't do a very good job. I think my takeaway for the talk is Nix just says, tell me what your graph is. And once I have your graph, I can do whatever I want with it. So there's Nix Package Manager that says, download the graph. Something like, apt-get or yum or whatever. So it says, you have a name, download the graph for me and let me install this package locally. NixOS says, here's a bunch of packages, turn them into an OS distribution, and let me run that. So they're all just different variants of, here are different graphs, put them together, and make them a thing. Yeah, what is Nix Shell? So Nix Shell, just to get a bit more pedantic, will download the packages, but it puts them in this separate Nix store thing, and then it just sets your path. So in Linux, how things are found is they do a search along your path. So the moment you do a Nix Shell, it drops you into a new bash environment with your path set with your path environment variable set with some new directories. So they're found. So it's like ephemeral to that single session. And what's great is there's no container, no namespaces, no C groups, nothing. So you're like fully native within the host. Sorry, the question is, does this work for alternate architectures? Things work. Ultimately, you're building third-party software, so the asterisk here is, do things work for alternate architectures, is going to be, does that software build anyways reliably for those alternate architectures if you're on your own? The other benefit is if using this large package set, authors have taken the time, and many of them are here, they're running RISC-V or cross-compiling, and they've submitted patches to make them work for alternate architectures. But fundamentally, Nix is architecture agnostic. Yeah, so, okay. So, where is it? Because Nix is this recursive hash calculation, a cryptographic hash of your stuff, if I changed even a comment in my source code, I went back to that script, what is my IP, and I put a comment. I functionally didn't change the thing. Asterisk will get a different hash because when it goes to build this big recipe file, so this is the recipe file that says, Nix, this is how you build this thing. It had here the text. That's the contents of the script. Like the contents of the script to change, and then therefore the hash changed. Again, this is recursive. That meant if I wanted to use a different curl and it only changed because of a comment, its hash would change and now my hash would change because I have a different hash in my hash. So I'd get a totally different output, and that's okay. They live side by side. The beauty of having hashes in the name is now they're not colliding spaces in the directory. They're just like sitting side by side in a big directory tree. If I want to go back, I delete that comment. If I perfectly delete it and the hash calculates back to the same thing, Nick says, you already got it there, buddy. I'm not going to do it again, and it skips some work. Again, really clear, that's not bit reproducible. Nix can do bit reproduction. This is a bit different. This is source reproduction, pessimistic reproduction, because the source changes always affect the hash. Okay, thank you. I'll be around. If you have more introductory questions, I'm happy to answer. If you have high-level questions, happy to answer. And I hope you learn to love Nix as much as I do. Thank you.